Hey everybody, Brad here with another post-repair video. This is for customer Jay. He sent this in. It's a Defender board set, complete minus the linear power supply. I already tested that. So I've gone through and basically repaired and rebuilt all these boards, restored them, and I'll kind of go over what I did. So the MPU here, this is the main reason he sent it in was every time the game booted, it would go to the bookkeeping screen, and he couldn't get it out of that screen into gameplay. In attempt to fix that, I think the battery holder and batteries were changed. These are nice AA lithiums in here now, phenolic battery holder. And I did reflow and clean up all the solder joints on those. I think the customer put in new diodes here, blocking diodes. Those sometimes do fail and lead to the CMOS being corrupted or not saved. They were good still. I did replace the electrolytic here. It was a radial that was installed with an axial tantalum, 22 microfarad, and that allows all the voltages on the board to come up and get stable. Basically, it's a time delay before the CPU comes out of reset. I also change a Zener diode here for the 5 volt circuit. This is supposed to, there's one that monitors 12 volt and one that monitors 5 volt. And this Zener, the original value is 3.6 volts, which really allows that voltage to get too low, where you'll end up with corruption of CMOS and things like that. So I replace it with the 4.7 volt. So anytime the voltage on the 5 volt rail gets to 4.7 below, it pulls the CPU into reset. Then we've got new Nichicon electrolytic filter caps here. We've got the -5, +5, and +12 here, all new. I replaced the round pin Molex headers with the newer square pin, much more surface area. So this is power, this is the interlock or memory protect, and then the video out here. And I'll go into more detail as to what we found with the CMOS going into bookkeeping every time and not saving the settings. Um, After this video, I'll follow up with another one and go into detail what we found here. But back here on the ROM board, again, new filter cap, all new Molex headers, cleaned up, cleaned all the pins, new 3M ribbon cables that I make up here, all NOS stuff. This one did need the board header on it. The old one was broken. Uh, IO board, same kind of thing, new cap, new ribbon that I make up, two new 10-pin Molex headers with square pins. And then back here on the soundboard, all new Molex headers, all new electrolytic caps. There's 8 of them on here that got replaced. Some of them, the aluminum ones, got replaced with tantalum in 3 locations. I do take the fuses out and clean the fuses, and I recrimp these little friction holders so we get a real tight fit. I remove all the screws between underneath the 7805 voltage regulator and the TDA 2002 audio amplifier and put new heatsink compound. And I also replaced the bridge rectifier on these. So real solid. I did pull the EEPROM and the 6808 CPU straightened, clean the legs, reinstalled. Everything looks good there. So we'll go ahead and get it on the bench here. And let me get it where I can get that in the full frame here. And we'll boot her up. I do have a little power supply on my bench here. So you can see now it goes right into a track mode, no bookkeeping thing. So everything's working as it should. I'll coin it up here, hit start. So you can see the gameplay's fine on it. So I did let this run overnight already, and it's real solid. So I'm going to follow up here in a minute with another video. For you, it should be a few seconds, and I'll go over exactly what we did to fix this thing. Hey all, Brad here, trying a little different format for this video. Just finished up doing what I would consider my normal video that I've done for a long time. That's typically just a customer follow-up video after I get done with the repair. I do before photos, in process, after, and then I end with a video that typically a customer will get, and then they can see, their boards from the time they arrived throughout the process and then leaving in a working condition. Um, It's helpful for me. It's helpful for the customer. I think people like it, and then I started sharing them on YouTube, and people seem to like it. The one thing they've been asking for is like, hey, can you go into a little more of how you troubleshoot, how you root cause, what the different problems are. So this is my attempt to do that. Let me know what you think. If you want more of these, I'd like to do some videos on the bench actually showing how I change components and the solder work and maybe some of the tools I use as well. I did that in a previous video. I showed the FPGA cat box, and but I've got scopes and logic analyzers and all kinds of goodies we could go into. So without further ado, we will go into here, sharing the schematic, and then let me get the mouse pointer up here. You should see it. Let me hit this. So this is from the Defender manual. This is a schematic. I've kind of isolated the area of the schematic that we're interested in, showing the CMOS RAM. Again, just to follow up, the customer sent this board in. The complaint was powers the game on, it goes right into bookkeeping and has no way to get out of that screen to get into gameplay. So right here is the CMOS RAM, a 5101, which is a 256 word by 4. How do they come up with that? Well, there's 8 address lines, 0 through 7, and then there's 4 outputs on the digital line here. So um, basically, as you through using binary count up, you get to 128, and then when A7 is enabled, that is 128 on its own. That's the value or the worth of that address line 7. So what they did, Williams being pretty smart, they said, we've got some data that's pretty critical to earning money. I think it was the main reason. For instance, whether the game is in free play as set or not, and they really didn't want people messing with that unless you had a key to the game, right? So what they did is, if we look over here, um, this is the 4-pin header um, on the board where you connect to the memory protect switch that's behind the coin door. So there's 4 pins here. Pin 1 is the one that goes up to the circuit that monitors whether that door is open or not. Key on pin 2. Pin 3 is ground, which is the other lead that goes out. There's 2 wires that go to that cherry switch on the front, and then nothing connected on pin 4. So the normal state here is when the door is closed, pin 1 and 3 are connected, so it's at ground. So if you follow this up, it would come over into 5B, which is a 7404 hex inverter. So there's 6 gates in there. Each one has an input and an output. 7404 is an inverter buffer. So basically, whatever is on the input, on the output, you'll find the exact opposite whenever you look. So if pin 3 is high, pin 4 will be low. If pin 3 is low, 4 will be high in this case. And there's 6 of those on each chip, 6 pair of gates. And when the coin door is open, not connected to ground, if you follow the circuit over, there's a 4.7K resistor R32 that one side is connected to 5 volts. So we call that a pull-up resistor. So what that'll do is when this side over here is floating now, it'll pull high, logic high. So pin 3 will be high and then 4 will be low. And you can see here bit address line 7 feeds into this gate, and that um, will not inhibit the read write on this 5101, if that makes sense. So if the door is closed, that's going to inhibit, and if it's open, it can write and write the data to that location, or overwrite data if there's already data there. So for troubleshooting this, it was pretty straightforward. Obviously on my bench, well, there's nothing connected here, so powered off and just use continuity, buzzer mode, just to see if there was continuity between one and ground. And sure enough, it was like something was connected. So I thought, well, maybe this little decoupling capacitor here, C61, which is a 470 picofarad or puff cap, was shorted. So I lifted one end. Nope, still connected to ground. So you track it back. And there was nothing, laying across or shorted or anything that was pulling that to ground. So really, that only leaves one thing that could have had that connected to ground, was an internal short to ground inside this gate. So pulled the 7404 off the board, desoldered it, and checked it again between that line and ground, and it was open now, no connection, and dropped in a new 7404 inverter and put it on the bench and tested the circuit, and it works exactly as it's supposed to now. So probably from the time, I normally do all of the headers and the ribbon cable and electrolytics and those sorts of things, kind of as a maintenance, if you will. I like to do it on all the boards because when I didn't, I'd send the board back, and typically if something came back, it was something like the ribbon cable had failed or people were having problems. So for me, just I like to make sure the customers are happy. It's really not much extra cost to do those things up front. Some people, especially in the electrolytics, there's a whole camp of don't replace them if they're not bad and all that. Won't get into that, but I do. Um, and so get that done, get it on the bench, and the time it takes to, in this instance, to troubleshoot this, get it on the bench, change the part, and retest it was probably 15 minutes, something like that. Pretty short time. Um, and then after that was done, then I go back and clean it up and check a few other things and actually test it by the interlock and try to rewrite the data and making sure that it does inhibit the right when the equivalent of what the door would be shut, pin 1 connected to pin 3 over here. So anyway, that's the follow-up on it. If you have any questions or you like this format, let me know. We can do more of these or less. It's up to you. So thanks for watching, and we'll see you back here soon. Thanks.